Hi guys, let's look at the next chapter. The next chapter that we start is tangents and intersecting chords. Because of the lockdown, a lot of portion has been deducted or deleted rather by the ICSE board. So given here is the syllabus for you. These are three properties that are there of tangents which are there in your syllabus. Rest everything has been deleted. The first two properties we cover in exercise 18a, and the last property we cover in exercise 18b. So because of this, there are a lot of cancellations in this chapter, which I will tell you as and when we reach that specific question. But this year you have only these three properties of tangents which are there in your syllabus. Let's move on. So if you have a circle and a line next to it, the position of the line can be in three ways. Either it doesn't touch the circle at all, which is our case 1, or it touches the circle at 2 points, or it touches the circle only at 1 point. So when the line touches the circle at 2 points, it's known as a secant. You can also look at secant as basically a chord which has been extended on both sides. So if AB is a chord of this circle, then CD is the secant of this circle. It cuts the circle at 2 points A and B. Next is a tangent which touches the circle only at 1 point. We use the concept of tangent a lot in physics, where we talk about circular motion. It says the direction of motion, or the direction of an object at any given point is given by the direction of the tangent at it. So if you look at this, then the direction of the object at this motion, if it is moving in this circular orbit, at this point the direction of motion is in this direction. After a certain amount of point, when it reaches, let's say, this point here, then we will draw a tangent at this point, and the direction of motion at this point is in this direction. So that's why the direction of the object keeps on changing. We use this a lot in physics as well. So let's look at certain properties which are there. The first one, the tangent at any point of a circle and the radius through this point are perpendicular to each other. So what does it mean? This is one of the most important, rather the most important property of this chapter. It says if AB is a tangent, P is the point of intersection of the tangent with the circle, and if I draw a radius OP which meets the tangent at P, then the angle OPA and angle OPB are 90 degrees. So the tangent and the radius make an angle of 90 degrees at the point of contact. A couple of more things. No tangent can be drawn to a circle through a point inside the circle. That's very obvious, because if you have, let's say this is my circle, if there is a point inside the circle, if I try and join any point line passing through this point, it will touch the circle at minimum 2 points. So that's why you can't draw a tangent from a point which is inside the circle. Only one tangent can be drawn through a point of the circumference of the circle, which means at point P there's only one tangent which can be drawn. No other line at this point will make an angle of 90 degrees with this radius. That's why at any point on the circumference, only one tangent can be drawn from that point, which means if my point here, let's say, is this, let's say Q, from point Q there's only one tangent which will pass and no other tangent. So only one tangent will pass through point Q, and with the center it will make an angle of 90 degrees. Done. Let's look at the next one. From a point which is outside the circle, only two tangents can be drawn, and both these tangents are equal. Let's look at this on the next page. So it says from a point, in this case P, two tangents can be drawn to a circle, only two, one on this side, one on the other side, and from any point which is exterior point, only two tangents can be drawn, and both these tangents are equal in length, and the tangents subtend equal angles at the center of the circle. The proof of this is not in your syllabus for this year, but I'll still go ahead and solve it because it's an extremely simple one. So the question is, I have a point P which is exterior point, and there are two tangents PA and PB. We need to prove that PA and PB are equal. So that's about it. and we need to prove that angle AOP and angle BOP are equal. To do this, let's join OA, let's join OB, and let's also join OP. So now that I've joined these two, let's look at the two triangles which are formed and let's see if we can prove them congruent. I already know that angle OAP would be 90 because tangent makes an angle of 90 degree with the radius. Similarly, angle OBP would be 90. Same reason. So let's just start writing. In triangle OAP and triangle OBP, what we have is point number 1. So 1, 2 taken. So 3. Angle OAP is equal to angle OBP is equal to 90 degree. We'll write the reason in a minute. Next one, OA is equal to OB. So these two lines are equal. Again, that's because the radii of the same circle. Radii of same circle. And then the last one is the hypotenuse OP is equal to hypotenuse OP. A reason would be it's the common arm. So hypotenuse OP is equal to hypotenuse OP. This is common side. We haven't written the reason for the first one. The reason would be tangent makes an angle of 90 degree with the radius at the point of contact. In this case, the point of contact is A. Perfect. So therefore, by RHS test, yes, a right angle, hypotenuse and side, right? RHS test, we have triangle OAP is congruent to triangle OBP, which means I have AP equal to BP. This is what we had to prove. It also means angle AOP is equal to angle BOP. It also means angle APO is equal to angle BPO. The reason for all three of them is CPCTC. That's what we started to prove. Let's move on. But this is again the second very important property, which is from a point outside the circle, you can draw two tangents and the length of both the tangents is equal. Let's move on. Okay, another thing which is important or is a derivation of what we just learned. If two circles touch each other, the point of contact lies on the straight line passing through the center. Which means if two circles touch each other, which means if I draw a common tangent, QR is a common tangent to circle 1 on the left hand side, and it's a common tangent to circle 2, which is on the right hand side. What it's saying is APB is a straight line. Why? Since it's a common tangent, this angle is 90, this angle is also 90, which means this obviously is a straight line because this is a linear pair. Similarly, in case these two circles touch each other internally, and again QR is a common tangent to both these circles, the center of these two circles and the point of contact would lie in a straight line. Let's look at the next one. Another concept which I need to talk about, direct common tangent. If I have two circles, one with center O, one with center Q, these two are AB and CD are the point of contact. So L1 and L2 are direct common tangents. It is a tangent to circle 1, tangent to circle 2 as well. And the other one is a transverse common tangent. In this case, again, let's call this L3, let's call this L4. These are common tangents to these two circles. Let's say this is point S, let's say this is point R. So the two circles, these are common tangents. In this case, the circles lie on either side of the tangent. So for L3, this is on the left hand side, S is on the right hand side. So that's why these are transverse common tangents. The questions may use this term, that's why it's important to know before we start. Now let's try and solve some questions from this chapter. Exercise 18a, it says radius of a circle is 8 centimeter. Calculate length of the tangent drawn to the circle from a point at a distance of 10 centimeter from its center. Let's just draw a rough diagram first. So this is the circle. There is a point which is 10 centimeter away. Okay, so let's say we are talking about this point somewhere here, and this is my center, and this length is given as 10 centimeter. Perfect. Let's call this point O. Let's call this point P, and let A be the point of contact of the tangent with the circle. So we need to find the length of radius, which is OA. So OA is equal to question mark. That's what we need to find. Let's see if we can use certain things that we already know. Extremely simple. Let's see. Let's first join O and A. So let's write number 1, join OA. Now number 2, angle OAP would be 90 degree. Angle OAP is equal to 90 degree. Why? It's 90 because this is the angle which the tangent makes with the circle at the point of contact. So tangent makes an angle of 90 degree with the radius at the point of contact. So that's the reason, which means I can apply Pythagoras theorem. Let me join, yeah, that's about it. So we've got this is 10, this is x, we don't know the length, and we need to find the length of the tangent. We don't know the length of the tangent either. This is x. Oh no, the radius is given, not x, it's 8. So this is 8, this is also 8. We need to find this length. If this is 8, then this is 2. Obviously my diagram is not to scale, my 8 is smaller than 2. Yeah, doesn't matter. So in triangle OAP using Pythagoras theorem, so what I get is OP square is equal to OA square plus AP square. OP square is given equal to 10. So 10 square is equal to OA square, that's 8 square plus AP square, which means 100 minus 64 is equal to AP square, which means AP square is equal to 36, therefore AP is equal to 6. The unit given is centimeter, therefore the length of the tangent is 6. Therefore length of tangent is 6 centimeter. Let's go to the next question. The next question is question number 2. O is the center of the circle. AB is a tangent at B. AB is equal to 15 centimeter. Okay, so AB is 15 centimeter. AC is equal to 7.5 centimeter. This is 7.5 centimeter. We need to calculate the radius. So let's just join OB. We know the angle here would be 90 degree. So if OB is X, OC is also X. Let's just write that down. Number 1, join OB. Point number 2, OC is equal to OB is equal to radius is equal to X centimeter. Now the next one is number 3, angle OBA is equal to 90 degree. The reason, if you notice, I have written both the concept that we've done till now on the same page for us to remember. It says radius makes an angle of 90 degree with the tangent, and two tangents drawn from an exterior point to a circle are equal in length. So these are the two concepts that we've talked till now. We haven't used the second concept yet in solving a question. We are still using the concept 1. Let's just write this. Tangent makes an angle of 90 degree with the radius. So that's why this is 90 degree. Now in a right triangle OBA using Pythagoras theorem, what I get is x plus 7.5 square is equal to x square plus 15 square. Yes, x plus 7.5 square is equal to x square plus 15 square. Correct, my substitution is fine. This is x square plus 2 into 7.5, that's 14, 15. 15x plus 7.5 whole square, that's 7 into 8, that's 56, and 0.25. This is equal to x square plus 15 square, that's 225. X square and x square gets cancelled. So what I have is 15x is equal to 225 minus 56.25. Let's subtract 225.00. This is 56.25. So this is 0.75. This is 4. So this becomes 1. This is 14 minus 6 is 8. 11 minus 5, that's 6. This is 168. Let's just confirm. 210 to 24. That's fine. Therefore, 15x is equal to 168.75. Therefore, x would be equal to 168.75 divided by 15. This would be, let's just do the calculation directly without dividing it further by 5 and 3. 15 into 115. This is 18. 15 into 115. That's 37. 15 into 2. 30, that's 75, so that's 5. So x is equal to 11.25 centimeter. Therefore, radius is equal to 11.25 centimeter. That's the final answer. Let's look at the next question. The next question that we do is question number 3. It says two circles touch each other externally at point P. So diagram is given, these two circles are touching each other at point P. Q is a point on common tangent. So what they're saying is this is a common tangent which they've drawn. Prove that tangents QA and QB are equal. So we need to prove that QA is equal to QB. And now we will try and use the second property which says from any given point outside only two tangents can be drawn. So if I call this circle 1 and I call this circle 2, the two tangents to circle 1 are QA and QP and they are equal. For circle 2, the two tangents are QP and QB and they are equal. So let's just write that down. Number 1, QA is equal to QP, and the second one is QP is equal to QB. The reason for this is tangent drawn from an exterior point to a circle are equal in length. So that's this common reason for both of them, which means since QA is equal to QP but QP is equal to QB, therefore QA is equal to QP is equal to QB, which means QA is equal to QB. That's what they wanted us to prove. Very simple. Let's look at the last question for this video before I leave you. Let's look at question number 5. Question number 5 says two circles of 5 centimeter radii, 5 centimeter and 3 centimeter are concentric. No diagram given, so let's just draw a rough diagram for our understanding. Two circles of 5 centimeter and 3 centimeter and they are concentric, which means they share the same radius, share the same center. So if this is the center of both the circles, my first radius is the radius of the smaller circle is 3, radius of the larger circle is 5. Calculate the length of the chord of the outer circle which touches the inner circle. Okay, so there is a chord which of the outer circle which touches the inner circle. Let this be the chord, let this chord be AB, and the point where it touches the inner circle, let it be P. Now I think you would realize that APB is a tangent for the inner circle. Yes, because it touches it only at one point. So let's just write that down. AB is tangent for smaller circle. Done. What we need to find is the length of the chord. So let's join OP and let's join OB, and O is the center of the circle. So join OB and OP. Do we know the length of OP? Yes, we know OP is the radius of smaller circle, which is equal to 3 centimeter, and OB is the radius of the bigger circle, which is equal to 5 centimeter. So OB is 5 centimeter, OP is 3 centimeter. This obviously is 90 degree. The reason is angle OPB is equal to 90 degree. The reason is radius makes an angle of 90 degree with the tangent. That's the reason this is done, which means now again I can apply Pythagoras theorem. So in a right triangle OPB, using Pythagoras theorem, what I get is 5 square is equal to 3 square plus BP square, which means this is a Pythagorean triplets, very simple calculation, which means BP is equal to 4 centimeter. We've done a property in the chapter circles. In fact, we've done that property last year in class 9, which says a line from the center of the circle to a chord which is perpendicular to the chord bisects the chord, which means AP is also equal to 4 centimeter. Let's just write that down. Point number 8, AP is equal to BP is equal to 4 centimeter. Reason, perpendicular from center of circle to a chord bisects the chord. Now we are looking at the external or the exterior circle or the bigger circle. Bisects the chord, which means BP is equal to 4 centimeter and AP is also 4. Therefore, AB is equal to 8 centimeter, which means length of chord is 8 centimeter. Done. That finishes this video for me. No homework questions for you. Thank you so much. Take care. Be safe. I'll see you in the next video. Bye bye.